All right. Good morning, good afternoon, and good evening, everyone. And as per your, what time zones that you're joining us. So we have a couple more minutes for the session to get started. So let's just give a few more minutes for the others to join in, and we'll get started with today's session with Varun Tummala. Thank you, and I'll be on mute for the next couple of minutes. Okay. Hi, everyone. Good morning, good afternoon, and good evening as per your time zones that you have joined us. Firstly, welcome and thank you for joining us for today's webinar. My name is Vikas and I'll be the marketing manager for Kellton for some time now, and we have Varun Tummala, who is the presenter for today's session. So even before we go into the actual session for today, so there are a bit of, housekeeping that I have to do in. If you have any questions during the presentation, please feel free to drop in your questions on the GoToWebinar panel, wherein Varun and myself will be taking up these questions at the end of the session. So we leave a floor for question and answers for 5 minutes. And let me also tell you that this session is being recorded, and the recording of this webinar will be available once the session is completed, and it will be sent through an email link. So in today's webinar, Varun will present the evolution of the latest technology enabling big data solutions. We will also try to familiarize you with some of the in-memory and big memory solutions and present a case for role of integration and these scenarios. So Varun Tummala is an IT manager in Digital Connected Enterprise BU with over 14 years of experience in enterprise applications, integration, and IT delivery. All right. So to just to give you a brief introduction about Kellton Tech, if you look at it, we started in 1993. We have been in the industry for the last 24 years, and started in Hyderabad as the headquarters, but slowly moved into different regions, Gurgaon within India, and UK, USA, Canada, and Ireland as well. We have been working with startups and Fortune 500 companies, and we have a core strength of about 1,500 plus people located globally, and helping close to about 700 plus customer base across the globe. and we are also listed on Bombay Stock Exchange, that's BSE, and National Stock Exchange, NSE of India. So we have been working with clients, as you see, we have been working with clients on different domains, wherein we say ourselves that we are the digital transformation is one of our DNA, and we have been helping and customers to move on their digital transformation journey. So if you look at it, we have worked for retail companies like J. Crew, Staples, Discount Tire, and within the energy utilities, we have been working with Duke Energy, Valero, and financials as Vantier and JP Morgan, and many more. And we have been also working on few of the technology expertise like IBM, Software AG, MuleSoft, and SAP, Informatica, and Red Hat as well. To just give you a brief introduction about our digital connected enterprise practice, we started this practice some time ago now, and we have been using the latest technology and service offerings from IBM, Software AG, MuleSoft, and SAP. And we have been bringing the right vision and strategy to your, digital transformation roadmap. And we, as we say, why people, come to Kellton Tech? We have been delivering excellent omni-channel customer experience through customized IT solutions, strategic mobility consulting, digital transformation strategy, and governance, risk and compliance with the help of technologies like IBM, Software AG, and efficient tools of digital commerce and marketing. So without doing much ado, let me just push this to Varun. So Varun will be helping us out on today's webinar with Varun. We have the beautiful audience right over there. So please go ahead, and we are looking forward for your session today.
Thank you, Vikas, and good morning, everybody. Thanks for joining our webinar on big data today. We really appreciate your time, and thank you for this opportunity to share our thoughts on this, big data phenomena. Before I start, I would like to thank our team at Kellton for helping in putting together the content in this webinar. Vikas, can you put yourself on mute? Thank you. And let's look at the agenda for today. In today's webinar, first we will try to put big data, whether you call it a problem, opportunity, or a phenomenon, into perspective with small example and few statistics. We can then look at real decision dilemma almost every big data customer faces nowadays. Then we will look at the evolution of data into big data in rather technical computing terms. Then we can look at types of data, atomicity of transactions and typical use cases using data. And then some challenges with the traditional databases where they fail to address big data problems. We will briefly touch upon in-memory solutions and their part in big data paradigm. Then we will try to present a case for importance of integration in big data solutions. Finally, we'll briefly touch upon the maturity in big data solutions. Now, I would like you to go back few generations to our grandparents' era, where a typical citizen or a consumer's data, or the data associated with one person, is recorded in a few books or records. When you combine the data per person in the world, you'll have an idea of that existed, the data that existed in the world at that time. During those periods, if you have DVDs which store about 4.7 GB worth of data per disk, you would have been able to fit the complete data in the world in few days. Like as shown here, by 1800s, you would have needed just about 500 disks. Whereas by 1990s, the data in the world grew to a container load of DVDs. Now, let's come back to present times and look at a typical consumer, and let's say him a digital citizen, where the data associated with him is in multiple shapes and forms, whether it is in social media, cloud computers, biometric data, e-commerce data, and his connected devices, and so on and so forth. It's used for just one person. Again, to put this in perspective, in order to put all the data in 2010 into DVDs, it would have taken a container shipload of DVDs. You will notice in the next slide that it's nothing when compared to the data in the world right at this point of time. And at this point of time, if you have to compare, it may take probably 10 or more of these ships containing DVDs. Now the world is changing, and here is another set of some real statistics on big data. Almost 90% of the data that exists now is generated in just last 2 years. We can imagine what is going to happen in the future with more number of mobile devices, social media activity, cloud growth, Internet of Things, and everything connected devices, API economy. The data volumes will only grow exponentially. Now, this graph here shows the growth of data over the period of time. If you see, you will notice the data is growing exponentially, and it is projected that by 2020, the total data will reach 40 zettabytes. That's 40 trillion gigabytes of data. And it is projected that by year 2020, there will be 50 to 100 GBs of data for each and every person. With these numbers and growth trends, we at Kellton believe the big data phenomenon is not going to go anywhere. It may take different shapes and forms, but it will still exist as long as the digital world exists. Now, let's look at the options we have to solve big data challenges for any enterprise. If you are looking to pick one product from this list, shown in here to solve all your big data troubles, you are in the middle of same dilemma as many of big data customers. At the same time, we at Kellton are responsible for advising best possible solutions for our clients, and we cannot even suggest any one or few of them to all of our customers. Rather, we believe every one of the customers is unique and needs customized solutions and advice, but we can discuss some common characteristics of those challenges. Each of these products approach differently and address different types of big data challenges. I think it is almost impossible to suggest one quick solution using one or more of these products which addresses typical enterprise big data problems in this short span of time, however common they may be. On the other hand, I think we should be able to discuss some of the major classifications on these challenges, use cases, and characteristics. This webinar is a small attempt to do just that thing. In order to do that, basically, I think it's important to look at the types of data that exist now. There are basically three types of data based on their structure. Structured data is data we usually see in the relational databases, Excel files, and other systems like mainframes, SAP, etc. And structured data follows some kind of schema or data definition and will nicely fit into rows and columns. Whereas semi-structured data here that wouldn't fit into any row column databases but carries its own schema or data definition. For example, XML, JSON, etc. And they carry the tags that describe the data they contain. On the other hand, if you look at unstructured data, it will neither fall under structured or semi-structured data, and it will not have any identifiable internal structure. This is usually binary data like social media data, audio, video, PDFs, and emails, etc. When we are talking about big data, I think we should pay close attention to this type of, particularly the unstructured data, as it consists of major portion of the data that exists in the world by size. This type of data, when stored, usually not searchable by normal means and almost unusable, unless, of course, it is identified and stored in an organized fashion. Once this organization is done, the items of this type can be searched, and we can obtain some beautiful insights using analytics. Some of these big data products we have seen earlier specifically address this type of data and challenges related to data, this type of data. Another classification of the enterprise data is based on the usage of the data in that enterprise. Here are three types: transactional, analytical, and master data. Transactional data is normally produced out of business events in the enterprise. Some examples of this type of data are like purchases, billing, payments, etc. This data is also generated out of online transactions like web orders, money transfers, etc. And it is usually stored in online transaction processing systems or so-called OLTP systems. And systems that hold and process this type of data is usually they usually comply with the ACID rules. Let's briefly talk about these ACID rules. ACID. A for atomic, which means transaction executes completely or not at all. What it means is that transaction should be able to roll back if part of it fails. C for consistent, transaction should consistent to the rules of the database that contains. And then isolation, transaction executes as if it was running alone with no other transactions. And then comes to D, which is durable. And with this, the transaction results will not be lost in the when the system or part of the system fails. The reason we are talking about transactional data is not because it is part of the big data, but it is critical to the business and necessary to be able to get insights out of big data when integrated and combined with big data. Typical big data products by concept will not be able to maintain this transactional type of data. We'll get into more details in the next few slides. And this type of data is usually stored in RDBMS. Next type of data is by usage is analytical data. Analytical data is used to gauge the business performance. This type of data is stored usually in online analytical processing or OLAP repositories such as enterprise data warehouses or data marts. This is usually processed. This is usually the processed data from transactional or operating data prepared for reporting and analytics. And reporting analytics use processed structured data, whereas big data real-time analytics use raw unstructured data in general to provide insights. Master data, the next type of data is master data, which is key to enterprise, key enterprise entity data, and it is usually non-transactional by nature, and it is persistent. It is usually smaller in size if you compare it with other types of data, but it is very critical to the to any organization. We typically don't consider storing in big data stores, this type of master data, but we use this data to combine with other types of data to get analytics, and business intelligence. Now, I think it would be a good idea at this point to look at how the databases that store data evolved over time and eventually become huge repositories to store and process big data. In 1960s, the data was maintained in flat file, in a file-based storage. They had all sorts of limitations like extensive programming is needed, duplication, high maintenance costs, and weak security. And then evolved the primitive or pre-relational database management systems. There were multiple such DBMS systems. One of them was hierarchical data model databases, which basically maintain files with parent-child relationships. Although they solved some of the earlier challenges like searching and avoiding duplication with better security, they still lacked standards and failed to maintain many relationships in the data. Then evolved the era of relational databases, or RDBMS systems, which pretty much ruled this space since 1970s and are still prevailing. And they are most suitable for certain types of data like structured, transactional, and semi-structured, with, of course, with some limitations we can discuss further. And they do comply with ACID rules, which we discussed earlier. And They support SQL for storing and retrieving data. SQL is structured query language. And in these systems, the data is stored in tables, or they are also called relations. Data in these systems or RDBMS systems is less redundant, using normalization, and they are highly available to meet business requirements, and they provide access privileges and data level security. And one important thing to note here is basically these systems enforce strict schema or data definitions, because of which basically they are not quite suitable for unstructured data, but they are very good candidates for structured and transactional data. Now let's look at some shortcomings or pitfalls of RDBMS systems. Although these challenges existed with them forever, they become more prominent in this big data era. For example, due to the nature of how data is stored in RDBMS, they cannot effectively scale out. Scale out in the sense horizontally, which means scaling into multiple nodes. And now let's see, quickly why. When the data is stored in relations or tables across multiple nodes, it is difficult to maintain some of the ACID properties we discussed earlier. Due to basically one or more might go down, or issues like keeping the data in sync in all nodes, etc. And they're also expensive to scale up. Scale up in the sense increasing the capacity on a single node to support high volume. And also there are limitations in hardware in a particular single node. Even if they are able to process high volumes of data, they cannot process particularly huge volumes of data. So obviously there are some limitations on the size of that data they can hold and process. And you will clearly notice the performance degradation as the volume grows higher and higher. In order to overcome these challenges of storing and processing huge sets of data, industry, database industry in particular has realized the need for databases to scale out into cluster forms or multiple nodes. And use cases for databases, to be present across different geographies are quite common, in the present times. And this is achieved by, basically compromising on consistency of data for availability and speed with NoSQL databases. In NoSQL databases, typically the data is split into blocks and stored in different nodes in the clusters. The data is also replicated across multiple nodes. And HDFS, which is Hadoop distributed file system, is responsible for storing the data in the clusters. Processing portion of the NoSQL databases are handled by a system called MapReduce. Essentially, in these NoSQL databases, each node is responsible for processing the data on that node, and there will be a central unit that controls the jobs on all the nodes. And NoSQL databases are non-relational by nature and with flexible schema. They are less expensive, and they can scale up and out massively. They can store and process huge amounts of data with high speeds. This picture right here is a comparison of performance between RDBMS and NoSQL databases with increasing volumes of data. You may notice how RDBMS fails to perform at higher volumes, and whereas NoSQL just maintains the performance regardless of the volume of data. Although NoSQL databases can handle huge amounts of data, like terabytes to petabytes, they have some inherent challenges. They cannot fully support SQL and searches. Searches usually in these NoSQL databases are programmatic. Data retrieval is less guaranteed when compared to RDBMS. and there are multiple vendors in the space with different approaches and multiple flavors and versions. They are still evolving basically, and most suitable. They are particularly most suitable for semi and unstructured data, but they're not, in general, very good candidates for structured and particularly transactional data. And then now, the data lakes. Recent advancement in big data is the advent of data lakes. They are mostly offered by cloud providers to store massive data, in the order of petabytes. They usually store raw unstructured data, and they usually come with or bundled with analytical solution. And they are provided in the clouds in general. There are some examples like Amazon Web Services, AWS Cloud, and Microsoft Azure, which provide this type of data lakes. And let's look at the in-memory data solutions now. It is another variety of big data solutions. They use the memory to store the data as opposed to storing it in disk. These are particularly important because speed matters more for big data, particularly if you'd like to apply real-time analytics and get faster insights to get a competitive advantage. One way to achieve speed is to avoid costly I/O operations to disk, but put almost all or part of the data into the memory. This makes perfect economic sense in the this time period, as the costs of memory are gradually, or if not drastically, reducing. You may see this graph here on how the memory costs are reducing. And if you compare the speeds in traditional disk-based operations versus memory, those are milliseconds versus nanoseconds, almost 1,000 times faster. They provide high throughput as well as high availability with failover capabilities. Current in-memory technology can distribute the data across clusters and available in multiple varieties like in-memory data grades and in-memory databases. They also come with off-heap storage with better memory management. And another dilemma which is faced by most of the big data customers is whether to have the solution on-premise or in the cloud. A couple of things to consider while making this type of decisions are size of the enterprise data or big data, type of the data, transactional, non-transactional, structured, unstructured, and sensitivity of the data, and data demands for the enterprise, security, cost, and benefits. It is very common to go for hybrid solutions where part of the big data solution resides on-premise and the rest in the cloud. Again, it better consider all the factors we just discussed. Now let's look at a case for integration. With all the things we discussed so far, you may very likely end up with the data solution, which is just more or like this you see in the screen. If not now, or in the near future, but eventually you may face this challenge or this type of scenario. This layout poses some challenges like data syncing issues, point-to-point integrations between data sources, direct exposure of data sources, mismatch in data types, stored in those stores like structured and unstructured, and the transformations, between these two data sources, transformation of data. But this sounds very similar to typical enterprise integration challenge with the data sources instead of enterprise systems. Enterprise integration systems are basically proven to handle this type of data. Um, Additionally, they basically they help encapsulate the data in the data sources, expose them as enterprise services, and they can aggregate the data from different data sources, help them participate in service orchestration. They also help expose the appropriate data as APIs with good governance, integrate with multiple clouds, and ensure good security. And these are the topics we just discussed. Last but not the least, we at Kellton believe big data solutions are still evolving, and there is abundance of vendors, options, approaches, benefits, and limitations. Important thing I think is to notice that major part of the solution is not just store the big data, but to be able to understand, analyze it, and get fruitful insights, which provide a competitive advantage to the enterprise. But with clear understanding of the big data requirements, strategy aligned with your business roadmap, we hope you will succeed in your big data initiative. And finally, we'll be more than happy to involve ourselves in your big data journey and be part of your success. And I hope this webinar made you more familiar with the subject, and with that, we open the forum for questions and answers.
Well, thanks, Varun. Thank you for that session today. It was very interesting to learn about the big data phenomena. So yeah, we have a couple of questions. I know we are running short in time. We are exactly on the schedule, but we have a couple of questions coming in. So let's take this two questions what we have in. We have someone asking in, are there any integration products for big data integration? That's the first question what we have.
Okay, yeah, sure. So most of the major integration products have either adapters or plugins available for integrating big data sources, with the big data source with other data sources, and as well as other enterprise applications also. For example, Software AG provides a big data driver for its, using its JDBC adapter. These drivers are basically good for Apache Hive, MongoDB, and Cassandra, something like that. Basically. Hope that answers your question. Vika?
Yes, Varun. That's I guess that should be good. So we have one more question coming in. What are the popular big data products that we have?
Yeah, sure. One thing we did not discuss in this webinar is individual products and their features due to time constraints. But we tried to generalize and discuss common characteristics and challenges of big data. And NoSQL databases are actually 4 different types: key value stores, document-based stores, column-based, and graph-based. Basically they do solve different types of challenges. So, but to answer your question, there are MongoDB, Cassandra from Apache, Redis, HBase, Couchbase, just to name few. But if you are interested, we can have separate customized webinars or discussions. Please reach out to any of us, and you can reach out to us any of these methods. And I am presenting our email addresses right now. Please feel free to reach out, and we are there to basically help at any time.
All right, that is helpful, Varun. Absolutely. To add to Varun's point, if you have any questions on the present webinar or the services what we do in, or if there is any IT technology stack that you want to have some assistance from experts, we are here to help you out, and we will be happy to probably look at and present the solution, and also provide you with customized webinars for you and your teams. So whenever you want to probably have these things coming in, please do drop an email to us, and we'll be happy to help you out on that. So that's it for today. We have So you have been an awesome audience, and as I mentioned earlier, we have the recording of this session session done. So I'll be able to provide you, maybe next 24 hours, we'll be able to provide the recording of the session through the email. So please be attuned for it. And we also have a few webinars coming in the month of June, and that's on the 15th and the 29th. So please stay tuned with Kellton Tech Updates, and look forward to see you over there as well. So thank you, audience. Thank you, Varun, and have a great day.
Thank you all. Thanks, Vikas.